Hello guys, this is Tamaskan from Skill Lab, and today we're gonna see beam analysis. As we always do, we will try to come up with shear force and bending moment diagrams for the beam that we are going to see in the next video or slide. So our today's beam looks like this. As you can see, we have point A here, we have point B, we have point C, and we have point D. So this beam is only supported at point D, which is fixed, and we have a uniformly distributed load, 5 kilonewton per meter from A to B. So we have 1 from A to 1 line, from B to C 2 line, from C to D 3 line. So let's go to SOLIDWORKS and open new. Okay, part sketch. So let's sketch. Let's select from plane. I think we have 3 lines, right? 1 2 3 3 lines. So let's draw 3 lines. Before that, the dimension is in meter, so we must change this inch into meter. And let's sketch from plane, line 1 2 3. Good. The dimension, we have 2 meter, 2 meter, and 1 meter, the final one. So let's say this is 2 meter, this one is also 2, and the last one is 1 meter. Am I right? 2 2 1 meter. So let's exit the sketch and let's go to weldment, as we always do. If you don't have this weldment tab, right click and go to tab and scroll down and you will get weldment. So let's go to structural member, let's select this and let's right click. So we don't need this. Let's draw our own beam. Let's delete this. Let's get this thing. One thing that I want you to focus is here. You can change it before. As you can see here, we have D and X, so let's change it into Y and X. Here we have now this part X and Y, right? X, Y, this thing. So we can apply the load in the Y direction. So let's go to simulation, new study. Let's say this beam analysis says 5. Okay, so before we go into our assigning our fixture, let's apply material. It doesn't make a difference, but in order to proceed into simulation in our SolidWorks, we first we assign a material, but there is no difference in the manual calculation because we don't need a material to know the shear force and bending moment diagram of a beam. Yeah, so we apply. We have you can see 2 2, right? Here we have our beam, point A, point B, point C, point D. So let's go to our fixture and fix the geometry. And at point D is fixed, right? I think this is point D. Okay, yeah, right. So let's insert the symbol size. Let's make it 500. Yeah. Okay, it's too much, right? 250. Show preview. Yeah, seems cool. Okay. So let's apply load now. Force. Now, from point A to B, we have a uniformly distributed load, which is 5 kilonewton per meter. So let's choose this beam and let's select this one. And it is along from plane, right? What I mean is it comes from the above and it goes downward. So let's select this. Let's reverse the direction. And how much was it? I'm not good at remembering numbers. It's 5, which this is in Newton, right? So it should make this is per unit length. It becomes Newton meter. So we have 5 kilonewton. So let's change it to Newton, 5,000, right? In order to make it more visible, let's make this 500. Yeah, this is our uniform distributed load. You can see it here. It's already assigned. right here. It's negative because it's in the downward direction, the same convention. Here we have the moment at point C, right? So point C means this one. So let's apply load, force. Let's select this joint along the form plane, right? So let's go to moment, this one, right? No way, what I mean is, sorry, this one, in the D direction. So let's just reverse the direction, and we have 60 kilonewton, as you can see, Newton meter, so 60,000, right? 1, 2, 3. Let's make it more visible, 500. This is our moment, right? I think we're done. Just simple, right? So let's see, or let's run and let's see our results. Here we have the beam. So let's go to results. Okay, so what I'm gonna see is the shear diagram and moment diagram. Let's go and define. So let's make it 100, the beam radius. Show maximum and minimum, and next this wind 10, right? So you can as I told you, sign convention, there is no another difference, only sign convention. We have 10 kilonewton, and you can see we have 10. Let's check the bending moment diagram. Let's check the bending moment diagram. Let's check the bending moment. Let's make this 100, and let's go chart options, show maximum and minimum. Let's make this one. You can even make this floating. Go ahead. So we got 30 and negative 30, right? So here you can see it, negative 30 and 30. The same, right? So simple. As I told this here, we have a sign convention. This is the thing. This is what it really looks like. This thing is for the bending moment, and this thing is for so we have negative 30 and 30. As you can see, the same thing happens here. So we can say these are both similar, right? So if you want to see, you can view two way. Here we have for bending moment, sorry, this is, yeah. So you can just split into windows, and you can see the results that you want. Just simple, like what I mean is, knowing the science behind this is mandatory, but also knowing how to solve it using SolidWorks is also mandatory, because you can just do a lot of calculations in a paper, and this is going to be wasting your time, especially in this century. So you don't have to worry about the calculation. Once you understand the concept, you can go with SolidWorks, or you can go a lot of softwares, ANSYS, Abacus, or another kind of softwares, and you can solve these things simply.